In the previous lecture, we have discussed the solution of Legendre's equation. Now, after the solution of Legendre's equation, we will discuss the concept of Legendre's polynomials. So, first of all, I am giving you just a review of the previous lecture. We have actually seen that Legendre's equation is in this form. It is 1 minus x square d2y by dx square minus 2x dy by dx plus n into n plus 1 into y equal to 0. This is Legendre's equation. You have seen already in the previous lecture. And you have seen that we have considered a series solution of this equation, and that series was actually a descending series, because I have told you that the descending series actually finds physical importance in solving the physical problem. It is necessary. So I have considered the series in descending order of power of x, and so this is the solution which we write for solution of Legendre's equation. And after this solution, we have obtained an indicial equation, and you have seen that the roots of the indicial equations were m equal to n and m equal to minus n plus 1. These all things we have discussed in the previous lecture. Then, when we consider the first root, that is m equal to n, and along with it we also consider that n is a positive integer, and we select a proper value of the coefficient a0, which is 1 into 3 into 5 into so on into 2n minus 1 over factorial n. In fact, when you consider these three conditions, that m is equal to n is a positive integer, and a0 has this proper value, actually in that condition we have seen that we get the first solution of Legendre's equation, and that first solution was denoted by this symbol Pn of x. And you have seen that this solution of Legendre equation is actually known as Legendre's function of first kind. And so the first solution, or you can say the Legendre function of first kind Pnx, was defined in the previous lecture in this manner, which I have shown in this equation too. So everything which I have mentioned here already we have studied in the previous lecture while we were discussing the solution of Legendre's differential equation. Now you can say that this Legendre function of first kind Pn of x, actually this is known as Legendre's polynomials of degree n. And from here you can see easily that the different degrees Legendre polynomial can be evaluated from this equation too. Let us say if you want to find the 0 degree Legendre polynomial, that is P0 of x, then what we will do, we will simply put the value of n equal to 0 in this series, and this series is actually a terminating series, you can see. But see here, if you put here n equal to 0, then 2n minus 1 will be minus 1, and that will be not a valid result, because we have actually considered that n is a positive integer, and you know 0 is neither a positive integer nor a negative integer. So when you will take n equal to 0, it means you are not taking either a positive integer or a negative integer. So in that condition you should only take this 1 and take n equal to 0. So you know this factorial 0 is equal to 1, and x to the power 0, this will be equal to 1, and the terms, second term, third term, and so many terms, all will vanish because n is equal to 0. So you can see this term will vanish, this term will also vanish. So we can simply say that P0 of x is equal to 1. Now if you want to find the value of P1 of x, then we will put n equal to 1 here. So when n will be 1, 2n minus 1, that will be equal to 1. So here only number will be 1. divided by factorial 1, 1 divided by factorial 1, that will be 1, and x to the power 1. So this will be simply x, and n into n minus 1, and we have taken n equal to 1, so this will be 0. So you can see only inside this square bracket x will remain non-zero, केवल x ही बचेगा, बाकी सारा टर्म 0 हो जाएगा. So you can see that p1 of x will be simply x. इसी तरह से अगर हम लोग p2 of x निकालें तो आप देखिए 2n minus 1 क्या हो जाएगा, 2 into 2 minus 1 that is 4 minus 1 that is 3. तो आपको 1 into 3 सेलेक्ट करना होगा और डिवाइडेड बाय फैक्टोरियल 2, सो दैट विल बी 1 into 3 डिवाइडेड बाय फैक्टोरियल 2. अब देखिए स्क्वायर ब्रैकेट के भीतर क्या बचेगा, x to the power n, it means this is x square, and minus 2 into 2 minus 1, that will be 2, and divided by 2, you can see here 2 at 2n minus 1, that is 4 minus 1, that is 3, and x to the power n minus 2, n is 2, so x to the power 0, so you can see this is simply 1 over 3, and so this will be 3x square minus 1 by 3, and result will be 1 into 3 divided by 2, factorial 2 is 2, and 2 into 3 x square, 3x square minus 1, and this 3 and 3 will cancel out, so you can see our result will be 1 by 2 into 3x square minus 1. So in this way you can find the Legendre polynomial of different degrees for different value of n. But it is not a very simple method, or to remember this series is not very easy. So in fact this Legendre polynomial we define in a compact form, and from that compact form you can evaluate the value of Legendre polynomials for different value of n very easily. So you can see, since it is a terminating series, and so we call it Legendre polynomial, and in compact form how we can define this Legendre polynomial. So in compact form, Legendre's polynomials are defined as Pn of x. How we can define it in compact form? I am writing it. This is summation k equal to 0 to n. As I have told you, it is a terminating series, so infinity will not be here. Actually, this series will terminate at a finite term, and this is the cause that it is used in physical problems. So I have taken the upper limit capital N. Later on we will define this, what is this n, and this is minus 1 to the power k into 2n minus 2k factorial divided by 2 to the power n into k factorial into n minus k factorial into n minus 2k factorial into x to the power n minus 2k. In fact, in this compact form, we can define the Legendre polynomials, but we have to know what's the meaning of this n. n का क्या अर्थ है ये आपको जानना होगा. अब देखिए how this n is defined. In fact, n इस बात पर डिपेंड करता है कि this capital N कि आवर स्मॉल एन इज आइदर इवन और इट इज ऑड, इस पर यह डिपेंड करेगा. सो इनफैक्ट एन इज इक्वल टू स्मॉल एन बाय टू. This capital N is equal to small n by 2, but when if small n is even, then you should put this capital N equal to n by 2. Then it means then the series will terminate at n by 2 terms, and this will be equal to n minus 1 divided by 2, but when if n is odd. So remember this. This capital N will be equal to n by 2 when n is even, and this capital N will be equal to n minus 1 by 2 if n is odd. And in this way, now you can find the value of Legendre's polynomial for any given value of n, or you can say of any degree of Legendre polynomial. From this expression we can easily evaluate. So now let us find some of its values. Let us say we have to find P0 of x. When you say P0 of x, it means you are taking n is equal to 0. So when n is equal to 0, then you should say that this 0 will be treated just like an even number, and so capital N will be also equal to 0 divided by 2, that is 2. So while we will evaluate the value of P0 of x, then capital N will be equal to 0 divided by 2, that is 0. So limits of integration, limits of summation will be only 0, because we have to sum up 0 to 0. It means आपको k का एक ही वैल्यू लेना है और वह है 0, और n आपने ऑलरेडी स्मॉल n 0 लिया है. तो नाउ इन RHS we will simply substitute k equal to 0 and this small n equal to 0, and you can see then what will be this P0 of x. You can evaluate. See, minus 1 to the power k, and k is 0. And 2n minus 2k, the 2 into 0 minus 2 into 0 factorial, and divided by 2 to the power n, the 2 to the power 0 because n is 0, into k factorial, the 0 factorial, n minus k, 0 minus 0 factorial, and n minus 2k factorial. So 0 minus, and k is 0, so 2k will be also 0 factorial, into x to the power n minus 2k. This is 0 minus 0. And so you can see minus 1 to the power 0 is 1, and factorial 0 you know is equal to 1, and x to the power 0 will be also 1. So this is simply 1. So P0 of x is equal to 1. You can see it. Now we will find the another Legendre polynomial P1 of x, and what will be this? You can see. When you say P1, it means n is equal to 1, and n is 1, it means this is an odd number. This is odd number. And if n is odd number, then you can see that what will be this capital N. As you have seen, when n is odd, then capital N, that is the upper limit of the summation, will be n minus 1 divided by 2, and n is 1, so this is 1 minus 1 divided by 2, that is 0. इसका मतलब हो गया कि समेशन का जो लोअर लिमिट है वो आप जान रहे हैं कि k इक्वल टू 0 है, लोअर लिमिट ऑलरेडी मालूम है, और अपर लिमिट भी 0 ही हो गया. सो अगेन देयर विल बी ओनली वन टर्म. सो यू कैन सी what will be p1 of x? अब आप ध्यान से देखिए, our formula says that this is -1 to the power k, and k का लोअर लिमिट रखेंगे, दैट इज कि लोअर लिमिट और अपर लिमिट सेम ही है 0, so this will be -1 to the power 0. Now 2n minus 2k, n is 1, you can see, so 2 into 1 minus 2 into 0, k is 0, factorial, and divided by 2 to the power n. So this is 2 to the power 1 because n is 1 into k factorial, and this is 0 factorial, k is 0, and n minus k. This is 1 minus 0 factorial into n minus 2k. So this is 1 minus 2 into 0 factorial and into x to the power n minus 2k. N is 1 and 2k is 0. Since upper and lower both limits are in fact 0, so there will be only one term. Now you can simplify it. See, -1 to the power 0, this is 1, and 2 minus 0 factorial, it means this is simply 2 factorial. And 2 to the power 1, this is 2. Factorial 0 is 1, and this is factorial 1, this is 1, and this is again factorial 1, this is 1, into x to the power 1, x to the power 1. So you can see this factorial 2 means 2, so this will cancel out, and our result is simply x. So you have seen that p1 of x is equal to x. p1 of x is equal to x. अब हम लोग दूसरा पोलिनोमियल फाइंड आउट करते हैं, p2 of x. So p2 of x will be what? You can see in this case n is equal to 2 and n is 2, it means it is an even number, it is even, and when n is even, then the upper limit of summation, you know, is what? Then this capital N will be equal to n by 2, n by 2, and n is 2, so this is 2 by 2, that is 1. It means in this case when we will sum up, then k will have two values, k equal to 0 and k equal to 1. So in summation there will be two terms. First term, in case of first term we will have to take k equal to 0, और दूसरे टर्म में हम लोग लेंगे k equal to 1. सो अब फिर आप इस फॉर्मूला को देखिए और इसमें जो भी n और k का वैल्यूज है उसको पुट करके इस p2 of x का वैल्यू निकालेंगे. सो देयरफॉर p2 of x, you can see the first term is -1 to the power k, और k का पहला लिमिट 0 लेना है, so this will be -1 to the power 0 into 2n minus 2k. n is 2, so this is 2 into 2 minus 2k. फर्स्ट लिमिट ले रहे हैं 0, so k is 0 factorial divided by 2 to the power n. n is in fact 2, so 2 to the power 2 into factorial k, so this is factorial 0, and into n minus k factorial. n is 2 and k is 0 factorial. Again n minus 2k factorial. n is 2 and k is 0 factorial, and x to the power n minus 2k. n is 2 and k is 0. Actually this term has come when you have taken the k equal to 0, तब आपको ये टर्म मिला है. Now plus, now we will take k equal to 1. k equal to 1. Why? You have seen that the upper limit of summation is 1, so now we will take k equal to 1. So minus 1 to the power k, and k is now 1. So 1 into 2n, so 2 into 2 minus 2k, the 2 into 1 factorial, and divided by 2 to the power n, the 2 to the power 2 because n is 2, into factorial k, k in this case is 1. So this is 1 factorial into n minus k factorial. N is 2, k is now 1 and factorial, into n minus 2k factorial. N is 2 and k is again 1 factorial, and x to the power n minus 2k. N, you know, 2 and 2k, k is now 1. So this is 2 into 1. 2 into 1. Now simplify it. You can see minus 1 to the power 0, this is 1. किसी चीज़ पर 0 पावर देंगे तो 1 होगा. And 2 into 2, 4, minus 0, it means this is factorial 4. And divided by 2 square, this is 4. Factorial 0 is 1 into factorial 2. This is factorial 2. And into factorial 2 again, because 2 into 0 is 0. So again factorial 2 into x to the power 2 minus 0, that is x square, and plus. Now see this second term. Since minus 1 to the power 1, that will be minus. So here put the sign of minus. So this is minus, and माइनस हो गया, माइनस 1 to the power 1 के लिए. 2 into 2, 4, minus 2, that will be 2. So this is factorial 2, and divided by 2 square, this will be 4 into factorial 1 is simply 1, and factorial 1 is 1. 2 minus 1, 1. Factorial 1 is simply 1, and 2 minus 2, that will be 0, and factorial 0 is again 1. So this is 1, and x to the power 0. And you know this will be what? This is in fact factorial 4. It means 4 into 3 into 2 into 1, and divided by 4 into 2 into 2. Factorial 2 is 2, x square, and minus factorial 2 is simply 2, 2 by 4 into 1, because x to the power 0 is 1. So see here, this 4 and this 4, this 2 and this 2 will cancel out, and so the first term is 3 by 2 x square, and second term is 1 by 2. So take this 1 by 2 as a common factor, then what will be our result? This will be 3x square minus 1. So you can see in this way that P2 of x we have evaluated, and this is 1 by 2 3x square minus 1. So in this way you can find Legendre polynomial of any degree for any value of n. So it is just for your homework that you should try to find the higher order Legendre polynomial. For your convenience, I am writing directly some of its values, but you should definitely try to evaluate this. So similarly you will find, when you will evaluate, then you will see that P3 of x, you will obtain that this is 1 over 2 into 5x cube minus 3x. When you will evaluate, you will get this result. P4 of x, ये हम लोग देखेंगे कि दिस विल बी 1/8 इंटू 35 x4 माइनस 30x² plus 3. P5 of x, when you will evaluate, you will get this will be 1/8 into 63x to the power 5 minus 70x cube plus 15x and so on. In fact, जब हम लोग फिजिकल प्रॉब्लम की बात करते हैं जहाँ फिजिक्स में इसका उपयोग होता है, तो इनफैक्ट दीज हायर डिग्रीज लीजेंडर पोलिनोमियल्स आर नॉट in fact found there. In physical problems we generally got P0 of x, P1 of x and P2 of x. यही significant होता है in case of physical problems. So to get this value you can calculate it, but whenever you will deal with physical problems you will find that only the first three Legendre polynomials are important.